Alright, in this video I'm going to cover codominance. So far you should have a fairly decent understanding on monohybrid crosses, which is the cross or a cross involving a single trait. We've learned incomplete dominance, which is very similar to a monohybrid where we are still crossing one trait, but now the heterozygous phenotype is a blending of the dominant and recessive traits. And now in codominance, it's similar to incomplete, but just a very slight difference. So if you look at the word codominance, right? We know dominance, that's going to be overpowering, but co means together. So in a codominance situation, when you have a heterozygous phenotype, instead of being a blending of the two, like it was in incomplete dominance, now it's going to be an equal mix of the two other traits. So both the dominant and recessive traits are equally dominant in the heterozygous phenotype. And again, heterozygous would be like big A, little a, where you have one dominant allele and one recessive allele. And phenotype is the physical appearance of an organism. So, for instance, if we were just to look at this, these are all metaphorical. This is not how life actually works. It'd be cool if it did, but it's not. If we have a dad with a horizontally striped shirt and a mom with a vertically striped shirt, and we were to get out a kid that is heterozygous, the heterozygous phenotype would be both vertical and horizontally striped. If we look at these bears, again, this is not how it works, but if we have a black bear crossed with a polar bear, the heterozygous phenotype, in theory, if this is the way it works, but it doesn't, we would get black and white bears, which would be panda bears. Likewise, if we were to cross a beaver with a duck, the heterozygous phenotype would be an equal mixture of the two, making it a platypus. Again, not how life works, but they're good metaphors to kind of hit this point home. Some examples of codominant traits. We see it a lot in cattle. So cattle can have red fur, they can have white fur, or they can be roan. Roan just means that they have equal mixtures of red and white fur. So this is a close-up of some of the fur in this area. So you see it's red and white. In a lot of flowers, right? We can have pink petals, we can have white petals, and the heterozygous phenotype is going to be pink and white petals. So both of the traits on the edges of the spectrum are going to be both present in the heterozygous phenotype. In chickens, we can have chickens with black feathers, we can have chickens with white feathers, and if we have a heterozygous chicken, they are going to have black and white feathers. So again, both traits are going to be present in the heterozygous phenotype. In more cattle, right, we can have black fur, we can have white fur, and you guessed it that the heterozygous is going to have black and white fur. Not sure if it's called fur. I feel like it might be called hair. I don't know. You guys can correct me when I get back, but yes. In humans, you probably have already heard of sickle cell anemia. We've talked about it when we were talking about mutations, right? So you can have, most of us are homozygous dominant, which means that we have normal shaped red blood cells. If you are homozygous recessive or little a, then you have all sickle shaped red blood cells. This means that you have sickle cell anemia. It's usually very fatal. However, you are resistant to malaria, which is the deadly disease that mosquitoes give you. But this will kill you without having to get malaria, because this causes a lot of blood clots. You can also be heterozygous, which would be big A, little a, where you have about half of your red blood cells are normal and about half of your red blood cells are sickle shaped. This does not kill you due to the shape of your red blood cells, and it also makes you resistant to malaria. Okay, it doesn't kill you from the shape of the red blood cells, but it does give you some mild symptoms of the disease. But this is a case where the heterozygous phenotype is actually beneficial to an organism. So to do a problem with codominance, it is set up the same exact way as we've been doing, the 4 steps. And this is going to be done a little bit more like the incomplete dominance questions instead of the monohybrid, because the first step is going to be where you list the 3 genotypes and tell me their phenotypes. So in this problem, we are looking at cattle. So we have red hair, which is going to be a capital R, and white hair is a lowercase r, are codominant, with the heterozygous having roan hair. Again, roan is red and white. A white cow is crossed with a roan bull. Cow is female, bull is male. I do know that about cattle. What are the genotypes and phenotypes and their percentages of the F1 offspring, also known as the, F1 generation, also known as the offspring? There we go. So step 1, we need to write out the 3 genotypes and define them. So we see red hair, I tell you, is a capital R. So red hair is going to be homozygous dominant, big R, big R. The heterozygous is going to be roan. So that means roan is going to be big R, little r. And then white hair, since I told you was little r, is going to be little r, little r. So if I'm crossing a white cow with a roan bull, that means that I have little r, crossed with a big R, little r to get these parents. The next step is going to be to do the Punnett square. So we are going to put one of the 2 parents up at the top, and we'll put the other one down by the sides. Does not matter which one goes where. I put the little r on top, big R, little r on the side, and then you just go through and you play Battleship. So this would be big R, little r, big R, little r, little r, little r, little r, little r. Next, we need to go through and do the genotypes and phenotypes. So you look here and you see that 2 out of the 4 offspring are going to have big R, little r, which means that they are heterozygous. So that would be 2 out of 4 is 50% hetero. And the other 2 out of the 4 are going to be little r, which is homozygous recessive. So that means 2 out of 4 is 50%. That's going to be homozygous recessive. For the phenotypes, we just look at our step 1 and match it up to step 3. So we see this is roan. This is also roan. Little r is white. This little r is also white. So if 2 out of the 4 are roan, that means 50% will have roan hair. And if these 2 out of the 4 are white hair, that means that 50% will have white hair. And again, this is not cut in stone. The babies, let's say that a white cow and the roan bull have 1 baby, there's a 50-50 chance that they'll either be roan or white. Doesn't mean that every other baby is going to be roan, every other baby is going to be white. It's just a 50-50 chance every single time. Next problem, we're looking at a different set of cattle. We have cattle with black fur and white fur, and the heterozygous is going to be black and white. A black cow is crossed with a black and white bull. What are the genotypes and phenotypes and their percentages of the F1 generation? So we're going to start with step 1, where we are going to write out the 3 different genotypes and define them. So black fur is big B, so that means black fur has to be big B, big B. The heterozygous is black and white, so we know that black and white fur is going to be big B, little b. And then white fur is little b, so that means that in order to have white fur, you have to be little b, little b. For step 2, we're going to show the cross. So we are crossing a black cow with a black and white bull. So a black cow is going to be big B, big B. a black and white bowl is going to be big B, little b. So there's my step 2. My step 3 is to put it into a Punnett square. So I'm going to put one of the parents on the top, the other one on the side, and then we're just going to go through and again play Battleship. So this is what you should get when you bring the letter down from the top and the letter over from the side. The next step is to find the genotypes and their percentages of the offspring. So we have a big B here, that's homozygous dominant. Another homozygous dominant here. We have a heterozygous, big B, little b here, and another heterozygous here. So we have 2 out of the 4 being homozygous dominant, which means that's 50% homozygous dominant. And the other 2 of the 4 heterozygous, which gives us a 50% chance, of being heterozygous. Then we need to find the phenotypes. So these 2 homozygous dominant are going to code for black fur. So that means 2 out of the 4, 50%, will be black fur. The other 50%, these 2 hetero, we know from step 1 are going to code for black and white fur. So the other 50% chance is going to be that they will have black and white fur. Okay, so really the only difference here is right here. Whatever this phenotype is, that's the only difference. We're going to do one more problem. So this is, we're looking at a certain type of flower that can either be red, white, or the heterozygous is red and white. So if we are crossing 2 red and white flowers, we want to know the genotypes and phenotypes of the offspring. So step 1, we're going to write out our genotypes and define them. I told you red petals is a capital R, so that means in order to have red petals, you have to have 2 big R's. In order to have red and white petals, you have to be heterozygous, which means that red and white is going to have to be big R, little r. And I told you that white petals is little r, so in order to be to have white petals, it has to be little r, little r. Next, step 2, we need to show what we are crossing. So we are crossing 2 red and white petaled flowers. So that means that we are crossing 2 of these. So we are crossing a big R, little r with another big R, little r. Step 3 then is going to be to plug it into the Punnett square. So I put my parents on the top and on the side. And then we're going to go through and play Battleship. We bring this big R down, this big R over. We bring this big R over, this little r down, big R down, little r over, little r down, little r over. And this is what you should get as your possible offspring. Next, we need to go through the genotypes. We see big R, that's homozygous dominant. This is heterozygous, another heterozygous, and a homozygous recessive. Remember, homozygous means 2 of the same. Heterozygous means 2 different. So this is homozygous 2 dominant alleles. This is homozygous recessive 2 recessive alleles. And these are heterozygous 2 different alleles. So this 1 out of 4 is big R, so that's 25% homozygous dominant. These 2 out of the 4 are big R, little r, which means heterozygous, so that'd be 50% hetero. And this little r down here, 1 out of the 4 is going to be 25% homozygous recessive. Lastly, we need to do the phenotypes. So the 1 homozygous dominant is going to code for red petals. So that means 1 out of the 4 is 25% red petals. Both of these heterozygous are going to code for red and white petals. So that's going to be 50% red and white. And this little r is going to code for white petals. So 1 out of the 4 is 25% white petals. Hope this is making sense. If it's not, send me an email and I will hopefully get another resource to you to help you out a little bit. But that is it for this video.